Hello, and welcome to the log solving part 1 video. So I'm breaking this up into a few different videos just because there are so many different rules to practice. So in part 1, we'll be practicing just a few of our rules, mostly our rearrangement or our log bay, as well as just talking about logs itself and what we can do with that. So we're going to be going over 6 questions from this Go Formative or from these blank notes, so feel free to take a look. And we're going to start with problem number 1. Now problem number 1 says that log base 16 of x is equal to log base 16 of 21. Now, just like when we were solving with exponents, once our bases were the same, we could cancel those out and just set the exponents equal to each other. Here, once we have only one log on either side of the equal sign and they both have the same base, we can cancel those out and just set the arguments equal to each other. In this case, x is equal to 21. Boom, done. That's all you need to do. So let's try another one. Let's try problem number 3. We're going to have log base 13 of negative 2v minus 6 is equal to log base 13 of 5 minus v. So in this case, 2 logs of the same base that are equal to each other means that we can cancel out those logs and just set the arguments equal to each other. So negative 2v minus 6 is equal to 5 minus v. So I'm going to start by adding v to both sides. Again, negative v is equal to, there we go. Minus 6 is equal to 5. I'm going to add 6 to both sides and get negative v is equal to 11. Then I'm going to divide both sides by negative 1 or multiply both sides by negative 1 and we get v is equal to negative 11. Let's try one more with this type of rule. This will be problem number 5. We'll have log base 20 of 63 plus, 3n squared is equal to log base 20 of 4n squared minus 2n. So 2 logs of the same base set equal to each other means we can cancel out the logs and set their arguments equal to each other. So 63 plus 3n squared is equal to 4n squared minus 2n. So I see things that are squared, I see things with a variable, and I see a constant. So I'm probably going to have to factor or use my quadratic formula. To do this, I have to set my equation equal to 0. Now you can subtract 4n squared on both sides. That's going to leave me with a negative n squared over here, and that's going to make my life a little harder. So instead, I'm going to subtract 3n squared on both sides, as well as subtract 63 on both sides, earning us 0 is equal to n squared minus 2n minus 63. And this is something that is factorable. So we're looking for two numbers that multiply to negative 63 and add to negative 2. And those numbers are going to be a negative 9, so n minus 9, and a positive 7, so n plus 7. So in this case, we're going to have 2 answers. And I'm going to set both of these factors equal to 0 and solve. So we'll have n minus 9 is equal to 0, and n plus 7 is equal to 0. So when I solve for each of these, on the one on the left, I'll add 9 to both sides and get n is equal to 9. On the one on the right, I'll subtract 7 on both sides and get n is equal to negative 7. So hopefully you've gotten the idea by now that if you have 2 logs equal to each other that have the same base, you can just cancel them out. So now that we've got that, let's practice some of our rearrangement or our log bay. So if we take a look at problem number 11 of log base 2 of n is equal to negative 1. So when I have just one log is equal to a number, that's when we're going to do our rearrangement for our base, answer, and exponent. So this is going to become 2 to the power of negative 1 is equal to n, or our base, exponent, and answer. Now we have a negative exponent here. I don't want that as part of my answer. So I think, well, what was my negative exponent rule? Well, I'm going to bring this down to the denominator of a fraction and make that exponent positive. So overall, our answer is n is equal to 1/2. So again, you cannot forget your exponent rules just because we're in a slightly different unit. Let's try 2 more problems. Let's move this up all the way. So let's try problem 13. We're going to have 7 log base 11 of x minus 3 is equal to 14. Now, again, we have a log is equal to something with a number, so we should use our rearrangement. But before we can do our rearrangement, we have to get rid of everything outside of the log, mainly this 7. So I'm going to start by dividing both sides by 7. So we get log base 11 of x minus 3 is equal to 2. And now from here, we can use our log bay rule and rearrange so that we have 11 squared is equal to x minus 3, or our base, exponent, and answer. So once we simplify this, we get 121 is equal to x minus 3. I'm going to add 3 to both sides and get x is equal to 124. Let's try just one more problem. Problem number 16 is -5 plus log base 6 of 9x is equal to -5. So we got a log on one side and a number on the other. We're going to want to rearrange, but first we have to get rid of everything outside the log, meaning this -5. So I'm going to add 5 to both sides. We get log base 6 of 9x is equal to 0. And that's okay. We can still do our base answer exponent from here and get 6 to the power of 0 is equal to 9x. Just keep in mind, exponent rules, anything to the power of 0 gives us 1. So again, base is 6, exponent 0, answer was 9x. So when we simplify, we get 1 is equal to 9x, or when we divide both sides by 9, we get x is equal to 1/9. So this is just practicing a few of our rules. We'll practice more on Thursday, or in the video that you hopefully watch a little bit earlier than that. So let me know if you have any questions. I look forward to seeing you in class tomorrow.